So in Chapter 11, we're going to start taking our unit circle and laying it out in a graph form. It's much easier to look at things as graph because it's a continuous movement, and our eyes and our human brain tends to understand that a little better than this lovely unit circle here. So what does that mean? Here's a better example. You probably grew up, and in your first grade class there was the picture of this lovely globe. And you all went over to it and probably just spun it and really didn't care about the countries. And then your teacher would yell at you and say, "Kevin, stop doing that. Johnny, sit down. Don't touch the globe." And then you got into your book. And it's a little hard to put a globe in a book. So they took the globe and they flattened out the countries so they'd fit on a page. And your mind, it's much easier to look at, say, North America versus China when you're looking at it on a graph, instead of spinning the globe back and forth so you can look at America, then you can look at China, then you can look at America, then you can look at China. So we do the same thing with the unit circle. And just to show you, I have this wonderful little video right here. Actually, it's not a video, it's a program. So here is my unit circle. Ta-da! And we're going to start laying out this unit circle along this graph. So here I am opening my unit circle, and if you can see, it's taking the height of the unit circle and transposing it on to a graph. So when I'm at 27 degrees, I have a height of such, and then they put it over here. When I'm at 27 degrees, I have a height of such, and that keeps moving. And look, at 90, we're at the tallest part of our unit circle for sine, so we're at the tallest part at 90 degrees up here. Then our heights start to get smaller till we're here at 180, where there is no sine, because there is no height, because a triangle can't be formed on a flat line. And then our heights start to reappear in the negative zone to our deepest point at 270, we're at our lowest sine. So we're our lowest sine, and all the way back to the beginning. So here is your sine wave. Now, sine wave's pretty easy to understand, and let's just see how easier it is to read off a graph than it is off a unit circle. So for example, if I asked you what is the maximum value of a sine, it's much easier to look at the graph because maximum means the top, and you go boom right here. So the maximum value is 1, which happens to occur at 90 degrees, or pi over 2. Whereas if you're using your unit circle, you'd have to say, okay, sine is my y value. I got a 0, I got a 1, I got a 0, I got a -1. Okay, so 1 is my height. See, it was just easier to look at the graph. Likewise, they could ask you, what's the minimum value of a sine wave? Okay, minimum. Boom, right here, -1. And where does it occur? Oh, it occurs at 3 pi over 2, or it occurs at 270 degrees, whether they're asking you to work in radians or work in degrees. And they could ask you then intervals. So intervals of, let's say, increasing. Where's this sine wave increasing? Well, that's why we have our friend the smiley face. Look at him. He's on a roller coaster. Bam! He's at the top. Get that red mark out of the way. So he's at the top there. So he had from 0 to pi over 2, he was increasing. Technically, this should be a square bracket because we're starting at 0, and from there on we're increasing. All right. Where else are we increasing? Somewhere else? Yes. Okay, he goes down way steep, but he's also increasing from here to here. So another interval of increasing would be at 3 pi over 2 to 2 pi. And since we're ending there, we can put a square bracket. Now, if you don't like the open and square brackets, you can go back to the traditional. This can be written as 0 less than or equal to x less than pi over 2. Or this is 3 pi over 2 less than x less than or equal to 2 pi. And likewise, we could ask you intervals of decreasing. And that's the fun part. So let's go put Mr. Smiley Face back at the beginning. So here he's increasing, he gets to his max, and woo, that's where he's decreasing. So he's decreasing, if they ask me for intervals of decreasing, we could say he's decreasing from pi over 2 to 3 pi over 2. And I'll use the open brackets. Or you could write pi over 2 less than x less than 3 pi over 2. Because when he is right here at 3 pi over 2, he's neither increasing nor decreasing. He's neutral, as right here. So his slope is 0, so to speak. That's going to be huge in calculus, but we're getting way ahead of ourselves. Okay, so let's make the smiley face big, because that means we're done.